Hi guys, let's wait a minute more for other participants to join us and then we can start. Well, hi everyone. I guess that we can start. Thank you for joining our FinTech Marathon. This is our second day of a 4-day webinar sessions, and I hope you will join all sessions during this week and enjoy all of them. My name is Ksenia, and I'm a moderator of today's session. And before we start, let me remind you just a few rules about how you can ask questions. Please put all your questions into Q&A box for the speaker who will be able to answer them after his presentation. So chat is just for you guys to communicate with each other if needed, but if you have some particular questions for the speaker, please put them in Q&A. And also, please remember that every day we have special keyword. Don't miss them. After 4 days, you can build a phrase and send it to employer branding mailbox. After that, we will be able to send you a gift. Let's check the number of attendees. Yeah, cool. So I would like to present our speaker, Sasha Bolotnov, who will be talking about metrics in software development. I'm passing the word to him, so please welcome Sasha.
Thank you. All right. Yeah, my name is Sasha. I've been in software development for quite a while now. And I'll talk about myself a little bit, not because I want you guys to know who I am. Obviously, you probably don't care, which is fair. It's more about the rationale to why this thing is, is there. Why do I talk about the metrics in software development? Why it's important? Why I have a bit of a passion for this. And I started as an engineer, and at some point I kind of flipped to be more on the development side, on the project delivery, program delivery. I've worked for various clients in different industries, and across different industries, across different client types, the questions that they ask are very similar. And I presented them as user stories here, but clients want you to build reliable software for them. They want high return on investment on that software. They want things to be done on time. They want the software to be safe, secure. They want to make sure it's reliable, it's dependable, it doesn't crash. And it was my work for many years to basically explain to the clients in measurable terms why the software that I build or my teams build for them is good. It was also my work to help them understand that it's efficient, that they get a lot of value for the money that they pay. Sometimes they would compare me with other vendors and say, well, this vendor's rate per hour may be cheaper than yours. How can you justify your high rate? And it all boiled down to me at some point to a system that everything that we do, we measure. And we convert this into indicators, we convert this into metrics that help us understand and judge on our efficiency, on the quality of the software that we produce, on the quality of the code, on the quality of the actual product, on the dependability of the actual product, on the efficiency of the teams, on the different characteristics that relate, let's say, to reusability of the components that we build. Do we actually build everything from scratch, or do we reuse, the components that we create? And if we use, how extensively? And it is it is an important thing, and I speak to I interview people, I speak to people, I speak to architects, delivery managers, various types of groups, and I typically ask them a question around, well, listen, okay, let's say you're a program manager, you have 10 projects, and you're gonna have a meeting with, the CIO of the organization that you deliver for, and you have an opportunity to give them one pager that will talk about the quality of the asset of the software that you built, that will talk about the efficiency of your teams, that will talk about the dependability of the software that you built, potential reusability of the software in other areas, within the organization. What would that one pager look like? And the typical answers are this. People typically say, well, I mean, we'll tell them that we QA'd everything, or we'll tell them that we have unit test coverage. We'll tell them, we'll tell them different things. But what I see across the industry a lot is that typically teams do not have a system in place that will address that. And I think it's important. I think there's a lot of benefits for the teams and for the engineering community and for the sort of, the business community to have those systems, to have systems where everything you do is measured this way or another. The data is out there. It's really a matter of just using the data in a certain way. And then using this data to do things better or improve things, or be able to react on certain things quickly, or be able to actually predict what's going to happen based on the trends. And I think one thing that is a good analogy of this, love is a gum, right? Little chunks of gum that you can buy. Every time you unwrap it, it'll be like one of these little papers in there. And I think what's fantastic about this is that this guy's figured out a way to break down love into small explainable pieces. And you have this collection of different characteristics of love, or different things that people do, that all collectively, I mean, obviously it's more of a joke, more of a, sort of entertainment type of thing, but it's a great analogy of taking something big and difficult to explain in simple terms on the surface, and breaking this down into individual elements that all collectively explain if something is love. And I think this is, a lot of this is what we have to do when we have to explain to some non-technical stakeholders why we believe the software that we built is good quality. Good quality, not necessarily because it has no defects, but good quality overall, including all the, scale sort of measures. And a good example of this is Formula One. So Formula One, the sole purpose of like driving in that little car and building the car, having the technical team around the car, having the drivers and everything is win a race, obviously. Very simple concept. They extensively use telemetry in driving those Formula cars for many years. Since really late 70s, 80s, they started collecting the data. They've been streaming data since the 90s, which is 30 years ago. A typical Formula car will have between 150 to 300 sensors, up to 2,000 telemetry channels that will push out the data with 2 milliseconds, give or take, latency, collecting, 1.5 billion, 2 billion, a little less more samples per race, and every 90 minutes of driving will generate about 5 to 6 gigs of data. So every given second, every given moment in the race, they will know exactly what's going on with the car. That enables them making decisions, making, adjustments, telling the driver what to do, telling the team what to do, seeing if there's anything that needs to be updated or changed, during the course of the race, solely for the purpose of winning the race. Now, the way I look at this is that if they do it, we should probably do something like this, because apart from building software products, we don't really do a whole lot of other things. So when I build something, I want to make sure it's good, it's cool, it's great, it's better than they could imagine. But if you look at the industry revenue, 2020 forecast revenue, Formula One versus IT industry that we're all involved with, the graph is right. It's just that you can't really see the formula here. This is formula right there. Like a tiny little hair compared to this. So technically, right, we should have fantastic capability from the investment standpoint, from the process standpoint, and mentally to actually invest in building similar telemetry that helps us collectively as teams produce software, and make it great. The idea behind collecting telemetry is obviously taking data and making sense out of this data. And I'm not trying to be, I'm not going to spend a lot of time talking about specific recipes like, hey, these are the 5 data points that you collect. You need to collect unit test coverage, you need to collect dependency, you need to collect this and this. I think there's really no recipes into play. And as I worked with different teams, we've been collecting different metrics or combining different indicators or building indicators that would work for a particular project or a particular context. And some projects relate on reliability more than performance, some of the other way around. Some projects are more focused on the actual cost per feature or the service quality or the uptime, etc. So every time there's a project, and I think project being a unique thing, is fair to say that unique projects may require a unique set of metrics, unique set of telemetry data that you process, but overall benefits across the board are very similar. One, you can navigate your context objectively. And for me, back in the day, being a project manager, being able to understand specifically what's going on with the project is really important. One thing people tell you, well, we think it's going to take us, 5 days to deliver, and sort of using it as an expert judgment for your estimate. Another thing is actually looking at your estimate data and then looking at your actual fact data and saying, well, I see, 40% delta. Or another way around this, saying, you know what, how about we collect all the historical data for the components that we built in the past, and we basically see if what we estimated right now aligns to anything that we did in the past, and look at how we estimated it, look at how much time we actually spent doing it, and then maybe try to use that figure into play. So that's one example of how you kind of use that data for the estimates, but it's not only the estimates, obviously, that you use telemetry for. But it's one of the examples where the data is available. It's just really a decision around using the data or not using the data consciously that gives you a benefit of being able to understand your context in more details and give it a much more objective stance. Early discovery of problems and issues, obviously, that's also important, and that gives you ability to steer your team, steer your progress, manage the expectations of your clients, manage technology as well. You can build metrics around, hey, if we wanted to adopt a new technology, how do we make a decision around staying with it or abandoning it in a point of time where it's not too late in the game? Like, how do we not let it go too far before we realize the technology is not going to work for us? Informed decision making. Obviously, big important piece of play. Make decisions based on the numbers you have at hand versus, feelings or opinions, or combining those into a robust decision-making process where opinions still matter and expert judgment still matter, but you also use numbers and, numerically measured things to contribute to that process. It also helps you understand the impact of changes. One of the things we do is when we do a change, we can see, it really made a difference. And measuring things around this change is pretty much the best way to see to measure the impact of the change. Understanding the impact of changes, obviously, ability to recourse quickly. So once you have the numbers, you see the dynamics, you see the trends, you can recourse. And identification and differentiation. It was important for me at some point to be able to talk to clients in a way that they understand where our values are. When clients tell you, well, listen, I paid this other vendor, 20% less than you guys. Are you guys giving me 20% more value? You can't really justify without having numbers. It's just almost impossible to justify anything like this without having the numbers at hand. So these are benefits of collecting telemetry data, building your own metrics, building your own insights on top of this data, and then using this data in your delivery. The measures, this is probably the only recipe kind of related piece. Now, this is how I see it. And again, every project is unique. Every team is unique in their own ways, obviously. Every client is unique. Industries are unique. The values are different. But I have always used this model as sort of the skeleton, as the starting point, as the baseline for building, measurements frameworks in the teams. And I've used three components that help me drive the methodology for it. Give me some entry points, some basic vanilla metrics, some very, primitive data elements that I can collect, or specific things that I can look for in terms of measuring it. The first one is common sense. Common sense is king everywhere. Delivery methodologies, selection of technology, selection of integration patterns, selection of architecture. If you don't use common sense, not really going to take you very far. I recommend you base everything of common sense. Scale and CMM have always been the two things that I've kind of looked after. Scale from the code quality perspective, and CMM from the process quality and process maturity perspective. Values from those combined cover pretty much everything here. And I have a little slide to go into just like a 1-minute overview of capability maturity model, which is basically here showing you the 5 levels of maturity that process-wise your organization, not necessarily your entire organization, but it could be your project program level or account level, where basically how mature your process is. And then scale, software quality assessment based on lifecycle expectations. I think this screen that you guys are seeing on the right-hand side is probably very familiar. A lot of you must be familiar with the SonarQube, for instance, or SAML. That will, give you these details. This is really a code-based focus, source code focused kind of system that has indices for different characteristics for, reusability, reliability, security, basically overall technical debt, and a model for managing the technical debt. based on where you are in the life cycle of your application. But I break this down, I sort of break this down into 5 areas. One obviously is the code quality. And for everyone, I listed a few very fundamental, very basic metrics that you guys can use. And a lot of those metrics can be vanilla, something that comes, as part of the package with SoraCube, for instance. And some of those could be SLAs that you and the client define collectively. Some of these could be complex indexes or complex measures that you be able to derive uh, your view at efficiency or your view at quality of a particular, integration point or a particular element of your ecosystem. Code quality, fundamental scale, I think, it gives you a very good overview right out of the box. Test coverage, obviously, it's still part of fundamental scale. Security compliance and CTO compliance, which is alignment of your code quality measures to the CTO strategy of the organization that you deliver for. The other one is delivery process maturity. How mature, some metrics around the maturity of your team that's involved in that process. Continuous integration and deployment maturity. There's different ways to measure this. A lot of teams, my teams and I, we would actually build our own kind of model that calculates this. And in a nutshell, it could be something as simple as, if I have to take 10 actions to get something deployed and tested and then report it back into my team on a change, what's the percentage of manual routines versus automatic? And then it gives you one number, 20% automated, 80% manual. That's probably not where you want it to be. But again, your project could be specific to the extent that for some reason you have so many manual steps in the process and it's considered mature. Context, scope and context management quality. How do we manage scope? How do we manage context? Do we do it, in a way that's efficient? Quality of the estimates. Some teams measure it, some teams don't. For some teams it's important, for some teams it's not important, based on methodology, based on the commercial terms that you're engaged with. Return defects ratio, how many defects have been reopened? Defects discovered too late. Do I have defects that discovered in production? Many teams do. How many? Is it 3% of my defects that that I have overall, or 50% of the defects? And if it's 50% of the defects that you discover in production, that's probably something to look into. Service maturity, again, for some teams it may not be a big slice, it may not be a big area, especially if you're not engaged in service delivery in general. But again, it's SLA compliance for response, for fixing, the things, repeatability of issues based on the RSA, RCA. Do you actually, once the issue had occurred, do you actually take measures that make sure that it doesn't reoccur again? Product quality. A lot of the metrics from the code quality and delivery process maturity contribute to product quality. Production defects per feature, complaints per feature, change requests per feature. Do we actually implement it or something? User feedback. And then cost per feature, obviously. Again, many teams don't look into this, but for a lot of the work that I have done in the past, cost per feature was fundamental. That it is actually, and for a lot of metrics, and I think cost per feature is also important here, is that it's not so much the number or the value, it's really about the trend. I mean, the value is fine, but the trend for specific ones is maybe significantly more important. Like cost per feature, initially, you start building something, you need to get a lot of components, you need to get your infrastructure set up, you need to get your databases, you need to get your messaging, this and that, And then you push out the first few features, the cost is through the roof. But then naturally, you know, the trend should be pushing you down to some extent where you start reusing things, you start doing things that are, you know, configuration build or something that, you know, keeps the cost per feature on par with expectations. And then you will see how in your system changes in any of the areas will reflect in other areas. And it's a very well connected ecosystem that operates holistically. And you know, building your system, understanding your values, understanding your objectives. Why am I measuring it? What I want to do through this measurement. Am I trying to just see where I am, or I'm trying to actually make certain decisions around this? Is going to drive this process. You may end up, you know, focusing on 3 areas. You may start by saying, you know what, I want to focus on code quality first. We'll just do code quality, and then we'll add process maturity, or we'll add cost per feature and other things, you know. And it's really up to you how you do this. And there's really no recipes. There are too many recipes to kind of list through to get there. But I think what's important is, and I'll go here for a minute. What's important here is really a common sense. So this is all these pictures are Google. This I love this. Data, information, knowledge, insight, wisdom, and conspiracy theory. So this is where you take it too far. But from the building sort of framework perspective, the way I have seen it work successfully is that you define your objectives. You need to define your objectives. You need to understand for yourself and your team why you guys are doing this. Are you guys doing this because it's fun? Are you guys doing it because you want to, you know, see you as a team can actually regroup to be a little more efficient? Are you doing this to address, you know, specific values of your team? Are you doing to actually to advertise yourself as a more efficient vendor in the competition? Are you doing this because the clients are asking for it? Define your objectives. Your objectives will drive will drive a lot of that. Build indicators. Build indicators that use the data points and combine them, compose them in specific ways that make sense as metrics. And only use data that makes sense to you. Like as much as you can derive value out of the data, use it. But don't try to use it. Like sometimes in some of the vanilla sort of things that I use, we report the size of the code base in thousands lines, kilos. And you understand, I have, you know, 54,000 lines of code in my solution. It really means nothing. It really means nothing. So, I mean, it is a data point, but it's not a metric. It's not a metric. But things like 100% of my tests do not fail. Unit tests do not fail, or integration tests do not fail. That's kind of a metric now. But I mean, listen, it's 100%. Does it mean that it's also 100% coverage? Or it could be like a single unit test that you built for the entire 54,000 lines of code solution that doesn't fail. That's a bad metric. So metrics are data composed into things that make sense, and ideally a lot of sense. You probably want to end up with having 20, 30, maybe 40 metrics, not many, so that you can still make sense out of them. But you want to build your indicators in the way that they make sense, not just sound cool. I mean, 100% test success is great, but if it's only 10% coverage, your overall metric should probably look, you know, at least amber. Get trustful data. Use the data you trust. Use the data that you think is right. Don't like the easiest way to lie to yourself here is just to use the data that you cannot validate. Validate your math. Make sure that when you compose things into metrics to try to derive the actual insight or wisdom out of this is right. You're calculating it right. You're using the right weights. You're using the right combinations or formulas, etc. That it does work. And it's the easiest way to validate this is to actually start making changes and expecting changes in the specific metrics that these changes should potentially influence. And then if you're not seeing those changes, or these changes are opposite from what you expected, start double checking on your math and seeing if you actually, got your things right. And then calibrate. Similar to continuous improvement process, which is fundamental to any delivery methodology, your metrics need to be continuously calibrated. You can't continuously improve them per se, because I mean, they're not bad or good. They're just things that help you objectify what you see around yourself in a numerical sort of way. But you can constantly calibrate them to see if you can actually, build relationship between them, if you can actually, redo the math around them to make them more meaningful for yourself and your team. Uh, I think I'm done with most of what I wanted to say. Let me look at the Q&A and start answering those things. What kind of tasks do you consider the most important? Unit testing, integration testing, end-to-end testing, etc. Any recommendation? Let me put it this way. I don't think any particular kind of testing is more important than the other. I think when I build software, what I want to do is I want to understand the kind of testing that I need to perform in order for this software to be reliable, high quality in terms of functional and non-functional sort of characteristics of the software that I built. Now, I would never advise between unit tests, against unit tests. I think unit tests are super important. I like the TDD, test-driven development concept, and I have seen teams do this fairly successfully. I don't necessarily believe that every single project can be done TDD in a sort of very common way. I think every project may have its own, and it's really architecture driven to me. It can have its own type of implementation for TDD. Like some people say, well, we're going to do Cucumber, we're going to do this, we're going to do that. And integration tasks, I mean, if your system assumes integration, you probably want to test those integrations. So again, I think there's no more important and less important type of testing that you do. I think your test strategy, and I'm not trying to make it sound big, but I think your test strategy needs to align to your architecture, to the capability of your team, to the functional and non-functional requirements for the software, and you probably want to be within the reasonable range. I think one of the metrics that you could use is to actually see the percentage of effort that goes into testing and fixing defects. So the way I look at this is, let's say I spent 10 hours building something. Collectively, as a team, analysts spend maybe 30 minutes building a user story and explaining to engineers what needs to happen. Then engineers obviously build the unit test, they built the functionality around this unit test, then they updated the integration test, etc. So let's say we don't know what their contribution into testing was in the 10 hours spent. And then let's say there's a defect. So someone has to, so the QA has to test it. So if they test it manually versus, let's say, automatic, they obviously spend more time. But then they found a defect. So the engineer has to come back from, he was already doing something else, right? So he sees that defect, and then he has to go back to this context. Okay, figure out, okay, this is the defect. Yeah, okay, I built it. So he has to replicate the defect. He has to find the problem. He has to fix the problem. He has to retest it to make sure it now works, right? He has to potentially update tasks, update this and update that, and then redeploy, get it redeployed automatically. And then the QA will have to revalidate it. So the way I see this is that you want your testing to happen in a way that ideally there's no more retesting, rebuilding, revalidating cycle. Now, if you're using a lot of labor to test the functionality, and especially if you do it manually, and it may seem that, well, listen, if my developers do it quickly, I can do it quickly every time. But like what I've seen is that poor testing initially, or insufficient testing strategy initially will actually burn more time than it should in the long run. So I would recommend, if you're thinking of the strategy for testing, I would recommend picking a strategy where you try to test everything nicely. You want unit tests, obviously. You want integration tests if it's a distributed system or integrates with other pieces. You want some mocks. You want some data-driven tests. Look into how you could automate it day one. It's going to be very difficult, not very difficult, but a lot of cases it's difficult to actually retrospectively do the testing right. So try doing testing right day one. Try to do everything right day one. And I think that would be successful. I don't know if I answered your question. I hope I did. If not, just ask something out and let me know here in the Q&A. What tools do you use to check of static code? Maybe Sonar. So yeah, well, Jenkins is not really. Jenkins is more of an orchestration tool. SonarQube, I think there's three products that fundamentally help you look into the code quality and things. SonarQube, it's one of the most popular. I love it. I think it's very easy to use, and it gives you very quick insights, and you can manage your own rules. You can manage your own quality gates. I think it's brilliant. A lot of the EDEs and a lot of languages will provide guidance and linting. Sort of, you could use lints for pretty much every language. Jenkins is more of an orchestration tool that helps you build this ecosystem to automate some of that stuff. Also, SAML, it's a commercial product. I think it was originally a C++ static code analyzer that the owners it was open source, and then the guy who was behind this, he sort of built SAML, which has both static analyzer and they have tools for engineers that integrate with your IDEs and help you predict sort of defects and say, you're writing this code, we think there's a defect. So before you even commit it or before you even started testing it, SAML will help you say, what, there's probably a problem that you need to fix. There's a lot of other tools out there. I can't just come up with names. I've just recently, like a couple of weeks ago, looked at something new that I liked. Tools come in all the time. Just explore it, and I think you definitely find something that works pretty well. But SonarQube obviously is probably the easiest to get going with. How can we integrate the metrics in its continuous integration, continuous deployment process? So I'm not sure I understand the question. Let me answer the question the way I understand it. If I haven't answered it right, let me know. From the continuous integration and continuous deployment process, there's two things that I typically measure, right? One is the actual automation. Is it 100%, 90%, or 20%? How long does it take my team to actually, once I did a change in the code and I pushed it, how long does it take to end up deployed and tested and then code reviewed, and if everything is okay, merged and then redeployed and retested, right? That's sort of this spin. Like, can I do it in 30 minutes? Obviously, given that a code review happens, I recommend code reviews, especially maybe initially. I recommend automatic rejection of toxic code. The way we did in some of the teams is that when you commit code that's not compliant, based on the quality gates that we have in SonarQube, for instance, your pull request gets rejected automatically, and you have to go back to the homework before you can actually get the code review. If it passes the quality gate, then it gets merged with the master, built and deployed, and then tested with integration tests, and everything is good, then only then it gets code reviewed. And then when it's code reviewed, it's actually merged into master. So the metrics, the way I look at this is the level of automation and the actual maturity. Do I have my process organized around it in a way that is sufficient for the team? Having every single pull request reviewed without automated checks for the quality of that code, or if the code actually builds, if the code actually runs and against tests, is, to me, it's not very efficient because it burns time from the most efficient team players sometimes. And you could probably reduce it by 50% at least by introducing those automated checks. So this is how I look at this. I hope it answered the question for you. Otherwise, let me know. Can you please elaborate on that conspiracy theory image? What kind of conspiracy are you referring to in the context? Well, I'm not really necessarily referring to a particular conspiracy theory, but what this image really delivers is, and it's not my image, it's all on the internet. It's that you can, you, it's you who actually build. Okay, let me put it this way: you have the data, you have unit test coverage per line, per function, per whatever. You have the lines of codes, you have, number of tests, successful, unsuccessful. You have all this data in your universe around your code. You have all this data in your universe around your process. We did so many user stories, so many got accepted, rejected, planned. We did estimates, actual, we did 100 days worth of estimates, 110 actual. So we have this data. You have all this data about everything that's happening in your universe. And it's up to you now, if you use the data diligently and build reasonable insights and wisdom on top of this by combining this into reasonable metrics, or you actually take it to an extent that you just build a complete conspiracy theory around what's going on, and all your data, all your conclusions are unreliable. That's pretty much what I was saying. It's really you who do this, not the data that does it to you. I hope that answers the question, Gaurav. Uh, can you please repeat meaning of these terms: fundamental scale, CTO compliance, CI/CD maturity, return defects per feature? So, okay, so scale is, as I said, right? Scale is a system, and Sonar Cube, I think, is one of the most prominent implementations of this method. It's a series of indexes that help you, and you can see them here: usability, portability, maintainability, security, efficiency, changeability, reliability, and testability. A series of indexes that are built automatically based on rules and syntax analyzers that help you judge on the quality of your source code. Not necessarily on the quality of your product, because listen, your code could be 100% on par with all the quality standards for the source code, but still fail every day because there's something in the infrastructure that just configured wrong. Or the actual topology of your services is such that it's just not worth working on. Now, CTO compliance, when I say CTO compliance, what it means to me is when I work for when I build software for an organization, I try to work with them and understand where their CTO guidance is in terms of, okay, let's say we're working for a bank. What I want to know is, list of their approved technologies. I want to know where they see them, in 5 years. Are they actually trying to adopt cloud and kind of try to do things in a cloud-friendly or cloud-native way? Are they trying to use managed services? Are they trying to go into a microservices kind of setup or Akka setup, reactive, or anything else? So I'm trying to find that direction and try to align what I do with that direction. What it gives us is that we can start building things not only future-proof, but also future-proof in that organization's context. Again, continuous integration and continuous delivery maturity. I think I answered part of that question earlier. It's really about how mature are we around orchestrating everything that takes us to take the changes in the code and deliver them into environments. It could be prod, it could be dev, it doesn't really matter. But is it automated, smooth, well orchestrated process, or something that teams have to do, manually? And that indicates the maturity for me as well. Return defects per feature. Again, some of these are just examples, some sample metrics that I use, and you won't necessarily use them. Return defects per feature is when I calculate if, let's say QA did a series of testing and they said we found 15 defects. engineers said, we fixed 15 defects. QA want to revalidate this. So they go rerun their test and they say, well, in the 15 defects that you guys fixed, we think you only fixed 10, 5 are still there. That's the return defects per feature. So if I had, all this done for one feature, that means that I had 5 defects per feature return, which is, it's not good or bad. Again, as a number, it's not good or bad. You might be having thousands of defects or all in your entire application could be, 22 million lines of code, which I hope not, but it's a number that is only meaningful in a particular context. Have you used any kind of analytics approach to join all pieces involved in software development and get useful insights? Well, yes. I mean, the entire process of taking your data, converting into metrics, and giving it weights, and building math around this is an analytical approach. I have built systems that help me and my teams package all this data together, retrieve some of that data automatically, and have all this data navigatable in a single sort of interface. But yes, of course. Unless I don't understand the question, but I hope I do. Hi, for many security testing projects, it's impossible to test each and every screen and button for a large application in a very short time. In these circumstances, what approach should be applied to testing if there's time constraint? Great question, by the way. So I think I'm not a big expert in the security testing, but there's different kind of slices of this, right? I think at the very fundamental things, tools like Faircode or even StoreCube, they would test the security of your code. And that there's a lot of diligence that goes into it. People literally collect specific exploits, and they see where in the code some code could be exploitable, like even regex. Regular expressions in Python sometimes could be potentially exploitable. Not necessarily from the access perspective, but from denial of service perspective very easily. So those scans will give you a quick kind of overview of what's going on, right? Fortify also scans your. I think Fortify can also scan your source code as well to give you some initial hints. Although I'm not a big Fortify expert, to be honest with you. Now, a lot of the security testing also can be done automatically, and I think things like Fortify, they do offer actually, let's say your application is a web application, and it will actually scan the ports, it will scan the pages, look for things in your pages and thing. And I have actually been involved in one of the discoveries that, not one of my projects, but one of the neighbor projects in the program that I dealt with, they started using Fortify, and Fortify found a few things in their pages that were not secure. So it helped them discover problems without even having QA people do the things manually. Now, I think a great question around, in this circumstance, what approach should be applied, but testing if there's time constraint. Now, to me, this is always a conversation of the balance and the priorities. If we think, if collectively, myself and the client, if we think that pushing something out the door is more important than making it 100% secure, then yeah, let's keep the timeline short and let's try to do the best that we can to do as much testing as we can. If we think that security of the application, security of the data behind the application, the clients behind the application is more important than the timelines, we extend the timelines. I think there's either compromise or no compromise. There's really, you can't really do, but I think automation is a big piece of this. As much as you can automate this, that's something that needs to happen. And also people, I think one of the things that I've learned to do right is that continuous integration, continuous deployment, your infrastructure bits and pieces, your task strategy should all happen before you lay the first line of code in your application. like literally. You shouldn't be developing any code until you have your integration environments ready, your continuous deployment. Do it. You love it. It changes lives. I'm sure it just changes lives. How do you recommend measuring the coverage of the functionality with high-level tests? For example, requirements traceability metrics. How else? How do you recommend measuring the coverage of the functionality? Okay, fair enough. So I'm not a big. I mean, I understand what requirements traceability metrics is. I think it's pretty cool. I'm not a big fan. I have never seen, well, not never, but I have rarely seen that large projects can retain this traceability accurate throughout their life cycle. So it's difficult. Similarly with Cucumber, I think it's a great tool. It's got great dialect. It's got a great population of people behind it, but I have not really seen large projects done in a Cucumber way, from the sort of user stories, that sort of machine readable dialect, all the way to testing done in this way. So I think the concept is great. Maybe there's something that we need to learn to execute the concept properly. I don't know, but the coverage, it's a great question. I think I would look at this again. I might need a little more context to know what kind of project that is, and what features are there, what features are. But I would probably look at this from the feature perspective. If I have a feature, I want to see, do I have a task that tests the feature, and you probably have to establish one thing that we learn through experience somewhat, is that having the feature and saying, well, I have a test of the feature, does not necessarily complete the story, because sometimes, well, there's multiple scenarios, there's multiple permutations of data that you have to use to make this test complete. So one of the things that helped us understand if actually the way we measure the test coverage is right is actually seeing how many defects we get after the QA has signed off on something. So if you get a lot of defects that come after the QA has said, hey, our tests have indicated everything is great, then it means that you might have a problem with the test coverage. So this is how different metrics will work together to indicate a problem. I hope it answers the question. What is a good test coverage percentage? 80, a reasonable goal? I think I'm not a big sort of proponent of saying a number. From the unit test coverage perspective, I mean, really, some code bases are configuration-driven code bases, and I've seen people try to do 100% and building unit tests around getters and setters and stuff, which I don't think makes sense. I can't say 80% is good or bad. I honestly, I don't want to be prescriptive, but I have, in my experience, right, anything below 60 would typically alert me a little bit and kind of make me go deep into this. And so I would probably, for myself, my kind of bar is around 60%. Anything below 60% is like, oh, something's going on. Let's see why. And that I'm talking about unit test coverage. And if you're talking about the overall functional coverage, then I'd probably recommend try to do 100% if you can. Obviously, sometimes you can't do 100%, and there's some manual stuff involved. But for the overall functional coverage, from the automation perspective, I try 100%. How can you balance the metrics that would make sense for the stakeholders versus the metrics that would make sense for the project development? I guess sometimes they coincide, but not always. How to manage different priorities in your metrics? I think it's a fundamentally great question. Thank you so much for asking this. So here's the deal. I just need a minute to kind of verbalize it. So this is why the question is great, and I think this is really an insight that I should have probably shared earlier. Again, thank you very much for asking it. Here's the deal. My motivation when I work with clients, my motivation is to actually have metrics in place day one. I had clients where they wouldn't bother. They had nothing in place, and I would start, collecting metrics and get project managers involved and, program, and them, all them great guys would start collecting metrics and showing them to our clients every week. Hey, here's the metrics, here are the metrics, here are the metrics. A few months in, you see the client asking other vendors do the same thing for them. And then they start comparing, oh, look at that. So I have never really been in a situation where the metrics kind of hurt each other. Like some metrics are good for us and some metrics are bad for us. This is another thing. What I have seen though is that once you start putting those metrics in, you can start going back to the client and say, well, you know what? We want to achieve this, but your process is organized in a way that it's almost impossible. We have to change the process. Or we have to, do something collectively to make sure that we collectively can cater to have those metrics work for us. And I've seen a lot of those stories where it really helped. So I think the balance is try to come up with reasonable metrics that make sense to you in the business. Again, there could be metrics and there could be SLAs. I think sometimes you may say, well, the SLAs they're asking are reasonable. Sometimes it's difficult to negotiate, but common sense is something that I typically use to negotiate SLAs. And SLAs that I can comply with, I typically just let go, let them sit there, and no problem. But in my experience, metrics that make sense for the business, metrics that make sense for the team, they contribute to each other, and they're typically in harmony. Can you please describe one of your typical project setup in terms of apps you use for measurement? I think the most typical would be just use SonarQube to start with, and then the maturity data around your process, the maturity data around the cost per feature, etc. We used to do it in Excel. I have spent some time looking for a system that could actually do it for me, and I couldn't find anything, so I just wrote my own. I should probably open source it at some point and let others use it, but the idea behind it was that we can derive metrics automatically, and we can type in metrics or data for metrics manually, and then it gets calculated at project, program, and account level, portfolio level. But if you want to get started, I would probably take SonarQube for the code base. I would build very basic metrics and use them to type in, punch in the data in Excel. I would probably start, if I wanted to measure the process maturity and other areas, I would probably start with 3 to 5 per area to not overload. And then as you grow, figure out a way to, to collect them together. Some teams use things like Influx and Grafana to actually feed the data and visualize them, both open source. And, you could use Elasticsearch for that. It comes with Kibana that you could use to visualize that data as well. You could use a lot of different, there's technology you could put together that could help you automate these processes around collecting data and packaging the data into metrics as you grow. But if I had to do it right now and I had nothing, nothing in my pocket for this, I would probably do Excel and SonarQube. How do I lead a fintech API integration across ecosystems? I'm not sure it's within the context of this conversation, but I think fintech API, I have done a lot of work in the fintech space, which I still love. I think for my kind of newer kind of thing that we did was that it needs to be a schema first. I think this is the foundation of this that we've chosen, and it has demonstrated that it works really well, is that it has to be schema first, and then not the other way. So there's two ways, right? Some people say, okay, we're going to build an API, then we're going to get Swagger or something similar to generate the spec, and then people can access our servers, see the spec, and cater to it. The way we look at it is that you get an open API schema, or Swagger supports a schema-first approach as well now in the newer days. We build the spec as a spec, and this is the contract between all the counterparts that are involved. That almost instantly gives you a server with a bunch of mock data that you could use, and then everyone starts integrating pretty much instantaneously. Every change that you want to do in the spec need to be approved by the major sort of stakeholders who are integrating. But again, everything being spec first gives you a few things. One, you have your contracts day one. You don't have to, you know. Two, you have this code generation capabilities, and code generation has been sort of wave. You know, it was popular 20 years ago. I know at some point people thought, you know, code generation is not right. And then Google, you know, came up with this gRPC concept where they generate code, and I think it kind of demonstrated that, listen, it's still a thing. Open API can do code generated approach as well. And you choose, right? You code generate, you don't code generate, you use configurations over it, etc. So I think the fundamental principle for me is that it has to be schema first. This is where it starts. This is where it orchestrates, and I've seen this be a much more successful approach than traditional data model or, you know, API model implementation before you actually spec it. I hope it helps. Well, I think yeah, you're welcome, Mildred. I think we have no more questions open, so I guess we can end it here then. Thank you guys very much for attending. I hope it entertained you somewhat, and I think I need to go to the last slide so you guys can see the magic word, right?
Thank you very much, Sasha. And for those of you guys who asked if the recording will be published later, the answer is yes, definitely. It will be published on Luxoft Corporate YouTube channel, as well as on Luxoft Facebook and LinkedIn accounts. So please subscribe if you haven't. And we will also send it to everyone who registered to the marathon. So thank you again, Sasha, and thank you to everyone for joining and for your questions. Hopefully see you guys tomorrow at our third talk. So
thank you.
Have a good evening.
Thank you. Have a great night.
Bye.